Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And in this session we are going to discuss this integral in which we have to evaluate this definite integral from pi by 2 to 3 pi by 2, and our integrand is the square root of 1 minus sine square x, right? So this integral is going to be a very interesting integral because here we are going to apply the concept of mod function, which is also known as absolute value function. So let us start. So let us quickly revisit the definition of mod function. Now see, mod of p is defined as positive p whenever p is positive, that is p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is negative, that is less than 0, right? So this is the definition of absolute value of p. Now here let us first call this integral as I, and let us first look at this integrand. So here we have square root of 1 minus sine square x. Now from trigonometric identity we know that sine square x plus cos square x is equal to 1. So 1 minus sine square x can be written as cos square x. So here square root of 1 minus sine square x is now equal to square root of cosine square x. So now our integral I takes the form that is pi by 2 to 3 pi by 2, and here we have square root of cos square x and dx, right? Okay, so now see, the mod function is also defined as square root of p square, right? So here square root of cos square x can be written as pi by 2. Here we have 3 pi by 2, and square root of cos square x can be written as absolute value of cosine x, because if we take p is equal to cos x, then square root of cos square x is equal to mod of cosine x due to this definition. So here we have dx, and now let us consider the sign convention of trigonometric functions in the four quadrants. So here we have the quadrants. This is first, this is second, this is third, and this is fourth. So here we have 0, here we have pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So here we have to integrate from pi by 2 to 3 pi by 2. That is, here we have pi by 2, and here we have 3 pi by 2. So we have to go like this, right? So it means we have to cover the second quadrant and the third quadrant. Now here we have the absolute value of cosine function. So let us see the sign convention for cosine function in these two quadrants, that is the quadrant second and quadrant third. So in the second quadrant the cosine function is negative, and in the third function also, third quadrant also, the cosine function is negative, right? So when we go from pi by 2 to 3 pi by 2, the cosine function is negative. So we can now write mod of cos x is equal to a negative of cos x, because cosine function is less than 0 when we go from pi by 2 to 3 pi by 2, or we can express this fact as when x belongs to the second quadrant or the third quadrant, right? So mod of cosine x is the negative cos x, because cos x is less than 0. So when we have p less than 0, then mod of p is negative of p. So here if we take cosine x as p, then mod of p is equal to negative of p, because p is less than 0. So now here we can write pi by 2 to 3 pi by 2, and here we have minus cos of x dx. So now we can easily solve this integral. We can take negative sign outside the integral sign. Here we have 3 pi by 2 and we have cos x dx. Now the integral of cosine x is sine x, and the limits of integration are from pi by 2 to 3 pi by 2. And here we have first we'll take 3 pi by 2. So here we have sine 3 pi by 2 minus sine pi by 2. So substituting the limits and taking the difference. So here we have sine 3 pi by 2, that is 270 degrees. So sine 3 pi by 2 is the negative of 1. And here we have sine pi by 2, which is plus 1. So we have minus, here we have minus 1, here we have minus 1. So this is minus minus 2. So minus and minus, it becomes plus. So we have 2, right? So the value of this integral is plus 2.